Today we will be learning about parallel circuits.
A parallel circuit is a circuit in which two or more components are connected across common points or junctions, providing separate conducting paths.
The three main things to remember about parallel circuits are: the voltage of each resistor is equal to the total voltage, and they are all equal to each other. Each resistor's current adds up to the total current sum, and this equation is I total equals I1 plus I2 plus I3. And the sum of the inverse of each resistor equals the inverse of the total resistance.
Here is a parallel circuit with two resistors. The total voltage of the circuit is 200 volts, and the resistance of the first resistor is 50 ohms, and the resistance of the second resistor is 20 ohms. In our table, the voltage will be 200 volts for each resistor because, like we said earlier, in a parallel circuit, the voltage is equal across each resistor to the total voltage amount. Then we solve for the total resistance. The equation that we use for this is 1 over Req equals 1 over R1 plus 1 over R2. We then substitute our values and the equation becomes 1 over Req equals 1 over 50 plus 1 over 20. After we have set this up, we have to find the common denominator, and we get 1 over Req equals 50 plus 20 over 1,000, which reduces to 7 over 100. Then we take the inverse of this number, and we get a total of 14.3 ohms. The second step is finding the current, and we use the equation V equals IR to solve. For the total, it would be 200 equals 14.3 times I, and I equals 14A. For the first resistor, it would be 200 equals 50 times I, and I would equal 4A. And for the second resistor, it would be 200 equals 20I, and I equals 10A. The third step is to find the power, and we use the equation P equals VI, and we substitute our values to solve. For the total, it would be P equals 200 times 14, and the power would equal 2,800 watts. For the first resistance power, it would be P equals 200 times 4, and the power would equal 800 watts. And for the second resistor, it would be P equals 200 times 10, and the power would equal 2,000 watts.
And that's how you solve for parallel circuits.